Implicit differentiation problems can be challenging, and even more so when there's trig involved and chain rule also. When you put all these things together, it can sometimes make kind of a difficult problem. So I wanted to show you an example of how to do these types of problems. And this actually came from last week's live stream. I'm doing a weekly live stream now at 5 Pacific, 8 Eastern every Monday night. So be sure to join us next week, and let's go ahead and jump on into this example here. So we're going to get started with this question here. We're going to start with an implicit differentiation problem. So we're going to find dy dx by implicit differentiation. And we're going to do that with this equation here, which is sine of x plus cosine of y equals sine of x times cosine of y. So first of all, a couple things to think about when you're doing an implicit differentiation problem. You always want to look at, in this case, it's telling us to find dy dx, which has a lot of information in itself right there. So you can look at when you have this d something over d something, whatever letter is here on top, you're going to want to treat that as your function, and whatever letter is here on bottom, you're going to treat that as your variable. So right off the bat, we already have some information just based on the question and what it's asking us to find, that we know we're going to treat y as a function and x as a variable. So the reason why that's important is we don't actually know what y is. And based on the equation that we are given here, we can't solve for y and figure out what y is. So we're not actually going to be able to, use typical methods of finding derivatives to find the derivative of y, since we don't know y. But when we're finding the derivative with respect to x, because in order to find dy over dx, we're going to have to find the derivative with respect to whatever our variable is. So that right there tells us that we're going to be finding the derivative with respect to x of both sides of our equation. So when we find the derivative with respect to x of our function y, which we know is a function of x, there's going to be a little bit of a trick that we're going to have to apply when doing that. So I'll kind of get to what that trick is when we get to that point in the problem, but let's go ahead and just kind of start with each side of our equation here. So first of all, to find the derivative with respect to x of this whole equation, we can kind of just break it down, term by term, basically. Think about this piece here first, then the cosine of y piece, and then this sine of x times cosine y. So first of all, to find the derivative of sine x with respect to x, that's going to be a derivative that you probably want to just memorize. The derivative of sine x with respect to x is just going to be cosine x. There's really nothing special there because this term right here only has x's, which we know is the variable. So as a result, we can just use standard derivative methods to find the derivative of that one term. Okay, so then this next term here, cosine of y, we are going to have to do something a little bit different there for that one, because this has a y in it, which is, like I said before, our function. So as a result, when we're finding the derivative of that function, which we don't know what y is in terms of x, we just know that it is some function of x. What we're going to have to do is use the chain rule to find the derivative of this term here. Because, when you look at this term here, this basically is a composite function, because we have a function y, which is plugged into another function, which is the cosine piece. So when you're looking at this cosine of y, we have to use chain rule where we have y being our inner function and the cosine being our outer function. So as a result, the derivative of this term here, cosine of y, like I said, we're going to have to apply the chain rule, which just says that we're going to do the derivative of our outside function. So the derivative of this cosine piece, the derivative of cosine is negative sine. So actually this isn't going to be a plus, it's going to be a minus because it's minus sine. So we're going to have minus sine. And chain rule says to do the derivative of the outside term, leave the inside term alone. So we're going to leave our y as y. And then we have to multiply that by the derivative of our inside term. Well, the derivative of y we don't actually know, because we don't know what y is. If we don't know y, we can't know the derivative of y. But since we're trying to find the derivative of y with respect to x, basically what you want to think about is what is some symbol or terminology that literally just means the derivative of y with respect to x. And that is exactly what dy dx is. So when you're taking the derivative of another letter, which you know to be your function, with respect to a different letter, which you know to be your variable, that's just going to be represented as d of whatever your function is over d of whatever your variable is. In this case, dy over dx. Then for the right side of our equation, we're going to have to do the product rule here because we have sine of x times cosine of y. So we have these two separate terms being multiplied together. So to do product rule, we kind of want to create like a little side problem out of that basically. So I'll just kind of go over here for a second, and we want to basically designate which function is going to be f, which we'll just go ahead and say is going to be sine x, and which function is going to be g, which we'll go ahead and say is cosine of y. It really doesn't matter which one you call which, as long as you're consistent throughout this little product rule sub-problem. Then we need to find the derivative of each of these terms. So derivative of sine x, just like we found over here, is just going to be cosine of x. When you only have your variable, there's nothing weird you need to worry about. But then to find the derivative of cosine y, again, we're doing the derivative of cosine y with respect to x. So we actually already found that right here. Remember, the derivative of cosine y with respect to x is going to be negative sine of y times dy dx. So now the product rule says that we're going to basically have to cross multiply these. So we do the derivative of one function times the original of the other one, and then add those together. So f times g prime, f prime times g is going to give us sine of x times negative sine of y dy dx. So that'll just give us negative sine of x times sine of y dy dx. And then we're going to do cosine of x times cosine of y, and then add that in. So plus cosine of x times cosine of y. Okay, so now, as I've done with a lot of the other implicit differentiation problems on my channel before, the next thing, once we've actually taken the derivative of both sides of our equation, which we've done at this point, the next thing we want to do is basically move all of our dy dx terms over to one side of the equation, and all of our non-dy dx terms over to the other side of the equation. So at this point, we can go ahead and do that. We'll just go ahead and move all of our dy dx terms over to the left, and then all of our non-dy dx terms over to the right. So you can see this term here, cosine of x, does not have dy dx in it, so we'll subtract that from both sides. And then this term here does have a dy dx in it, so we'll move it over to the right. So since it's a negative, we can just add that term to both sides. And we will want to add that over here as well. So what that's going to do is it's going to cancel this term on the right side. It's going to cancel this term on the left side. And we're going to have sine of x times sine of y times dy dx. And then minus sine of y dy dx on the left side of our equation, and on the right side we're just going to have this cosine of x times cosine of y minus cosine of x. So now, once we've gotten all of our dy dx terms on one side, all of our non-dy dx terms on the other side, at that point what we can do is, since every term over on the left side of our equation here, in this case there's only two of them, since both of these terms both have dy dx in common, we can actually factor that out of them. And the reason why this is a really important step is because once we pull the dy dx out of each of these terms, we're just going to have this one dy dx in front here. So that's just going to leave us with dy dx times sine of x times sine of y minus sine of y. So the reason why it's important to do this step and to get to the point where we only have one dy dx is because what we're going to be able to do next is basically just move all of the other stuff over to the other side of the equation, which is just going to give us one dy dx all by itself on one side of the equation. So now we can divide both sides by all of the stuff that we have in the brackets here. That's just going to give us dy dx equals cosine of x times cosine of y minus cosine of x all over sine of x times sine of y minus sine of y. Well, I hope you found that video helpful. If you did, please be sure to hit that like button down below. Subscribe to my channel while you're there. also, and be sure to hit that bell icon as well so you're notified of all my new videos, including next week's live stream, Monday night, 5 Pacific, 8 Eastern. See you there.